All right, hello everybody. This is the lesson video for section 4.4. All right, 4.4 is all about two things: conditional probability and independence. All right, so our first learning target is we're going to be able to find and interpret conditional probabilities using two-way tables. We actually won't get into that on this lesson video, but when we go over practice problems in class, we'll do that as a class. Second one is we are going to be able to find conditional probabilities using the formula that's given down here. Then the third thing that we'll talk about is what it means when two events are independent and how we can figure that out. All right, so first thing we're talking about conditional probability. That is just when what's the probability of something occurring given that one event already occurred. All right, so an example would be given that it snowed a lot tonight. No, given that it snowed 6 inches tonight, what's the probability that we will have a snow day tomorrow? All right, so when we have two events, one event is already given that that event happened. What's the probability of the other event happening? All right, and this is the formula that we use. All right, and this is kind of the notation that we use. So in this case, given event B happens, what's the probability that event A happens? So my snow day example, and we actually do a snow day example when we do a practice for one of our practice problems. But like for that example, given that was, sorry, okay, back up. What we would do is we would need to figure out what's the probability that it snows 6 inches. All right, so you have to figure that out. And then given that then we would have to figure out the probability of it snowing 6 inches and also getting school off the next day. All right, and then we would just plug in those probabilities, and then that's how we would get the conditional probability. All right, so this is the kind of formula that we use, and it's actually quite a bit easier when we have like a two-way table available, which we'll do one of those in the practice problems. Next, we'll talk about what's called independent events. A and B are independent if knowing whether or not one event has occurred does not change the probability that the other event will happen. All right, so an example of independent events would be flipping a coin. Right, if you think about flipping a coin, if I flip a coin and get heads, and then I flip it again, chances of getting heads or tails is still 50-50, right? Like the coin doesn't have a memory. It doesn't remember what it previously got, and that doesn't dictate its next result. So those two results would be independent. All right, and what these formulas kind of represent is probability that, let's say event A is that you get flip a coin to get heads, and let's say event B is you flip a coin a second time and you get tails. All right, so what this would say, given that the second time you flip a coin you get tails, what's the probability of getting heads? If that's the same as probability of not getting a tails second and then getting a heads first, and it's also equal to flipping a coin and getting heads the first time. If you were to actually figure that out, you would realize all three of those probabilities are the exact same. That's kind of what these formulas are really telling us, right? So how to calculate it is you just do this process here. If all three of those are equal to each other, and all three of these are equal to each other, the events are independent. That means knowing the outcome of one event doesn't have any, doesn't affect the other, the outcome of the other event. All right. So sorry for jumbling my words. Like I'm having a tough time talking, I guess. But we're good now. All right. So thank you for listening, and we will go over some examples in class. But thanks for listening, and peace.